Okay, so we made a matrix just by picking some random numbers from -10, random integers from -10 to 10. So here's our matrix. So this is our A, and then our B was -4, -6, -9, -4. So do you know how to solve this? What would you do if I asked you to solve AX equals B here?
I mean, usually what you would do is you'd reduce the matrix and then try to find the special solutions. Just work like that. But that's a complicated process.
Yeah, well, anything with a 4x4 is going to be complicated. So we did check that the determinant of this matrix is not 0. In fact, it's -5,958. By the way, are you surprised it's so big, that determinant?
I mean, not really. We have a lot of fairly large numbers, so it's not too surprising. I mean, multiply like 4 or 5s together, you're already pretty big, and we've got bigger numbers than 5, so it's not that surprising.
Okay, so we're not going to find all of the x's for this, but let's say I wanted to find what x1 was. So what computation would you do?
So you'd have to pick a new matrix and replace this 8, 1, -8, 0 with this, -4, 6, 9, -4.
Okay. How can you do that? What would you do to do that and not try to do it in a simple way without having to type everything in? Sorry about that.
I guess we'd just... So I'm just going to copy this down here. I'll call it...
Can you scroll that down to the top now?
Yeah, I just need to grab... I'm going to grab this. And then put that in here. And then matrix from C should be... Oh, it's not. Oh, okay. This does it in the rows. Okay.
Yeah. So
I need to get this back. And okay, so this is back to our starting matrix, and we just need to type in -4, -6, 9. And -4, and there's the first column replaced, and there should be no other differences.
Okay, great.
So then we need to do determinant.
Here, scroll. Get this move up. Yeah. Okay. So great. So determinant. Okay, capital D.
Oh. Determinant C. 12,878, and then we can divide that by -5,958. Oop, what did I do? So the percent divided by -5,958. Is that what it was? Yeah.
All right.
Maybe n of that if we wanted.
Yeah, go ahead and do n of that. I'm going to do, what is it, 6,439?
Divided by 2,979, that's negative.
2,979 negative. I'm just writing it down.
Okay, so.
What? That doesn't seem like that's 0.00. Oh, it's because, yeah, percent takes the very last thing, so.
Okay.
879. There we go.
Minus 2.16.
Okay, great. And now let's see if we do another way we could just solve AX equals B is X equals A inverse times B.
Mm-hmm.
So let's take A inverse. Inverse A. Okay, so here's our inverse matrix.
Yep.
Here. And if I take D times V, I get minus 6439 over 2979, which is exactly what we found. So that's pretty cool.
Mm-hmm.
So somehow that vector b encodes the solutions when we use Cramer's rule. So cool. So now I want to show you a new example that's a little bit of a calculus review. It's also half review, half brand new material that shows where you can do a simple thing like this in calculus.
Okay.
All right.